Now let's quickly examine quadratic inequalities. So what is quadratic inequality? A quadratic inequality is a function inequality whose degree is 2. So now if you recall from a quadratic equation, so if I write an expression such as x squared plus 3x plus 5 is equal to 0, you know that this is what? A quadratic equation, because the degree, highest degree here of x is what? To the power of 2. So I know that when I have the highest power to 2, then I know that that is a quadratic equation. So in the case of a quadratic inequality, the only difference is that instead of having the equal to sign, they're just having an inequality sign. So for example, if I write x squared plus 3x plus 5 is less than 0, then this is what? A quadratic inequality. So how do we deal with problems like this? First, we have to solve the equation like you would solve a normal quadratic equation, but there is a difference after the factorization step, and that difference is what we examine using the following examples. So first, we want to try to solve this question in which we are told that x squared plus x is greater than 6. So as we normally would do if it was a quadratic equation, we have to make sure that what is at the other side or the right hand side is 0. So we have to bring this 6 to the other side. So we have what? We have x squared plus x, then minus 6 is greater than 0. So now that I've expressed it in this form, what would we do? We'll factorize like we would a normal equation. So we just factorize by multiplying the first term and the last term, which gives us what? 6x squared. So now we ask ourselves, what two numbers would I multiply together to get 6x squared minus 6x squared? Sorry, x squared times minus 6 give me minus 6x squared. So what two numbers would I multiply to give me minus 6x squared? But when I add those two numbers together, I will get plus x. So that turned out to be what? To be 3x and what? 2x and minus 2x. So 3x times minus 2x will give me minus 6x squared, while 3x plus minus 2x will give me plus x. So I will replace this with this. So I have what? X squared plus 3x minus 2x minus 6 is greater than 0. So I factorize, x is common to these first two terms. So I'm left with x plus 3, and minus 2 is common, and I'm left with what? X plus 3 is greater than 0. So what do I have? I pick one of those, one of x minus 3, and I have what? X minus 2 is greater than 0. So now this is where the difference comes in. So if it was to be an equal sign that was here, so what would you do? You will equate each of these terms to 0 and try to look for the value of x. But that is not the way you proceed with the quadratic inequality. It requires you to think more deeply of the problem. So now we are told, or we have found, that what? X plus 3 multiplied by x minus 2 is a number that is greater than 0. So what does it mean? It means that when I multiply these two quantity, x plus 3 times x minus 2, the number I get is greater than 0. So you would think, in what scenario can I multiply two numbers in which the product of that two numbers will be positive? And that is fairly easy to think about. So when I multiply two positive numbers, like two positive numbers, what do I get? I get a positive number. The result is a positive number. So in this case, for this condition to be satisfied, for the product of these two numbers to be greater than 0, is either these two must what? Be greater than 0 individually. So what would that mean? So that would mean is either x plus 3 is greater than 0, and at the same time x minus 2 is also greater than 0. So these two numbers are positive. So if you simplify this, what do you have? You have x must be greater than minus 3, and at the same time x must be greater than 2. But now you just have to pick one of these. And how would you go about that? You try to express it in the number line. So on the number line, when I try to write this out, I have what? 0 here, and I have x as 3. So x as 3 of minus 3 rather will be somewhere around here, and I have x of 2 as somewhere around here. So x is greater than minus 3 means that x comes all the way down here, and x is greater than 2 means that x come all the way here like this. X greater than 2. So as you can see, In the equation, you have to pick one of these two inequality that will satisfy all condition. And what would that be? It will be what? X to be greater than 2. And why is that? Because when x is greater than 2, as you can see, these two lines overlap with each other. So the condition that satisfies both this inequality and this inequality is the condition in which x is greater than 2. So when x is greater than 2, I know that this condition is fulfilled and this condition is fulfilled. So yeah, I pick out what? X greater than 2, and let me circle that with red pen. So now, in what other way can the product of two numbers give me a positive number? So let's think about it. So in the first scenario, we said that two positive numbers, the product will give me a positive number. So think about it. If I multiply two negative numbers, the product will also be positive. So the product of two negative numbers is also a positive number. So another way in which this can turn out is if these two numbers are what? If they are individually, if they are less than 0. So if x plus 3 is less than 0 and x minus 2 is less than 0, then the product of those two numbers to be greater than 0. So here I have what? X is less than minus 3, and I have what? X here is less than 2. So now I'll try to represent this on the number line also. So to do that, I indicate my points. I have what? 0, and here I have minus 3, and here I have 2. So I have x is less than minus 3 over here, and I have x is less than 2. So as you can see from here, which conditions satisfy both conditions? As you can see, the two lines intersect with each other at the point in which x is what? Is less than minus 3. So what I will select out of these two is what? Is x less than minus 3. So applying those two conditions, I found that what? This equation can be solved when what? When x is either greater than 2 and or when x again is what? Is less than minus 3. So I try to combine these two into a number line graph to get my final result. And to do that, I just draw my number line and have my 0 here, and here I have minus 3, and here I have what? I have 2. So now I'm told that what? The first condition, x is greater than 2. So I have x being greater than 2. And the second condition, x is less than minus 3. And the second condition, I have x being less than minus 3. So the solution to this equation is what? Either x is greater than 2 or x is less than minus 3. So when you have these two conditions, then this inequality, this quadratic inequality will be satisfied. Now let's look at another example. So in this example, we proceed like we would. So first, we already have this as being less than or equal to 0. So we can factorize directly. So we factorize by multiplying the first term and the last term, which gives us what? Minus 4x squared. So what two numbers can I multiply together to give me minus 4x squared? When I add or subtract, I'll get 3x. So that is pretty straightforward. That will be 4x and minus x. So 4x times minus x will give me minus 4x squared, while 4x plus minus x will give me 3x. So I can replace 3x with this. So that gives me what? X squared plus 4x minus x minus 4 is less than or equal to 0. So x is common to these two, and I have what? X plus 4. And minus 1 is common to these two, and I have what? X plus 4 also. So this becomes what? It becomes x plus 4 and what? And x minus 1 is less than or equals to 0. So how do we think about this? Now the way to think about this is quite different from before, but it still follows the same logical reasoning. So now we have the product of two quantities, x plus 4 and x minus 1, which is less than or equals to 0. Less than or equals to means is either 0 or it's a negative number. So when you multiply two numbers together and you get a negative number, what does it mean? It means that one of that number must be positive and the other must be negative. So there are two ways in which this can be achieved. Is either this first quantity is positive or greater than 0 and this is negative, less than 0, or the other way around, this is negative and this is positive. So we start is either, so the first condition or the first way now is either this quantity x plus 4 is positive, so it's either x plus 4 is greater than 0 while x minus 1 is less than or equals to, sorry, there are an equals to sign 0. And when we do this, we have either x is greater than or equals to 4 and what, and x is less than or equals to 1. So if we try to solve this on the number, if we try to think about this now, so what condition of number of x can satisfy these two? So you think about it, x is greater, sorry, this is going to be a minus 4, x is greater than minus 4 while it is less than 1. So we try to draw this out on the number line graph, and when we do this, what do we get? We have a 0 here, and we have a 1 here, and we have our minus 4 here. So x is greater or equals to minus 4, so we have something like this going in this direction, and we have x is less than or equals to 1. So x is less than or equals to 1 coming like this, and I don't need to explain why the circle is shaded because I've done it before. So as you can see, the range of equations will fall in between this region, so I can write the range as what, minus 4 is less than x, which is less than or equals to 1. So now the second way now, or the second condition or way, any way you want to refer to it, is if this first quantity is negative, the other way around, x plus 4 is less than or equals to 0, and simultaneously the other quantity is positive, so you have x plus 1 is greater than or equals to 0. So in this case, I'm going to have x is greater than or equals to minus 4, and at the same time x is less than or equals to, sorry, x is what, x is greater than or equals to 1. So if we think about it, there's a mistake here. Okay, yeah, sorry, there's a mistake here. So it's either x is less than or equals to minus 4, or x is greater than or equals to 1. Yes, sorry for the mistake. So it's either x plus 4 is negative and x minus 1 is positive. So when you solve this, you have x is less than or equals to minus 4, and you have x is greater than or equals to 1. So now you can think about this. What two condition, what values of x can satisfy this condition? Now think about it. Can you have a number that is less than 4? That would be like minus 5, minus 6, minus 7, and at the same time that number is greater than 1. This is not possible, so this is not sensical. So we do away with this second condition and we stick only with this first instance. And in that first instance, what have we got in our result to be? We have gotten our result to be what? Minus 4 is less than or equals to x, which is less than or equals to 1. So we just sketch it out on the number line. I have our 0 here, and we have our minus 4 here, and we have our 1 over here, and we just sketch this, draw here, and we have a shaded circle. We draw here also, and have a shaded circle, and we join it together. So we have minus 4 less than or equals to x, which is less than or equals to 1. So this shows how to solve quadratic inequality. So the thing to remember is that after the factorization step, you need to think about the sign. So if you are told that it's both less than or equals to 0, then you know that 1 is positive and 1 is negative. So you have to try for both conditions. But if you are told that it's greater than or equals to or greater than 0, you know that both numbers are either positive or both numbers are either negative. Then you're trying to solve it. So now we have been expressing the result in the number line as you have shown here. But how would you represent the results of quadratic inequalities on the Cartesian plane? So let's quickly look at that. So representing quadratic inequalities on the Cartesian plane. So now if you remember from your quadratic equation, when you draw a quadratic equation graph, what do you get? You get a curve. You get a parabola, to be precise. So what determines the orientation of the parabola? The parabola can either face down like this or go up like this. So what determines it? As we will see, the orientation or the standard form of the quadratic equation, the standard form of a quadratic function is y is equals to ax plus bx plus c. The parabola will open up if a value is positive. So that means if the coefficient of x squared, as you can see here, this is ax squared over here. So if the coefficient of x squared which is positive or greater than 0, the parabola will open up in this manner, as you can see over here. But the parabola will open down in this manner if there is a negative coefficient to x squared. So if the coefficient of x squared is negative, then the parabola will face down like this. So you have to memorize this, because this gives us a quick and easy way of trying to sketch quadratic graph that will come in really handy. So now let's try to solve some examples. So what are the steps when we want to solve or represent quadratic equation on the Cartesian plane? First, we have to solve the inequalities of the quadratic equation. Then we need to sketch the quadratic graph. Then we need to shade the required portion. So let's apply that procedure to solve this example. So first, we are told that x squared minus x minus 10 is less than or equals to 2. So what is the first thing we have to do? As you know, you have to bring this to the other side. So we are left with what? X squared minus x minus 10 minus 2 is less than 2. So we have x squared minus x minus 12, sorry, is less than 0. Is less than 0. So now we factorize. When we multiply these two terms together, we have what? Minus 12x squared. So as I said, what two numbers can I multiply together to get minus 12x squared? But when I add or subtract those two numbers, I get what? Minus x. So that is what's going to be minus 4x and what? 3x. So minus 4x times 3x will give me minus 12x, while minus 4x plus 3x will give me minus x. So I replace minus x with this. So I have what? X squared minus 4x plus 3x minus 12 is less than 0. So we'll proceed now. X is common to both terms. So we have x into bracket x minus 4, and plus 3 is common. We have what? X minus 4 is less than 0. So what do we have? We have x minus 4 and what? X plus 3 is what? They are both less than 0. So what do? We apply our two conditions. So now if the product of two quantities is less than 0, it means that either one of them is positive and the other is negative. So we start with the first condition by making this positive. So it's either x minus 4 is greater than 0, while x plus 3 is less than 0. So when we solve this, what do we have? We have x is greater than 4, and at the same time x is less than minus 3. Now if we think about this, this is really nonsensical, because you cannot have a number x in which the value of x will be greater than 4, like 5, 6, 7, and simultaneously the value of x will be less than minus 3. It does not make sense. So we disregard this result. So we look at the other one in which this x minus 1 is a negative number. So the second scenario now will be a scenario in which this is the negative number. So it's either x minus 4 is less than 0, while x plus 3 is greater than 0. So let's think about this scenario. So in this scenario, we have x being less than 4 and having x being greater than minus 3. So this is really reasonable, because we can have numbers that are greater than minus 3 while at the same time they are less than what? 4. For example, 1 and 2. 1 is greater than minus 3 and at the same time is less than 4. So let's start out by representing this on the number line, even if that is not what our goal is here. So we have, just to recap, so we have what? We have 4 over here and we have minus 3 over here. So since we are just dealing with strict inequality, it's just going to be a circle over here and a circle over here. So we have what? This. So this represents what? Minus 3 less than x, which is less than 4. So this is the result of the number line. So how do we represent this now on the Cartesian plane? So the first thing you have to do is you have to what? Sketch the graph of the Cartesian plane. So which we'll do. So once you sketched it, you label your axis. You have x and you have y over here. Then now you determine the roots of the quadratic equation. The roots represent the point in which the curve or the parabola is going to cut the x-axis. And if you look at your solution over here, you can see that the roots are what? 4 and minus 3. So the parabola will cut the x-axis at the point in which x is what? Minus 3, and at the point in which x is what? 4. So once you have located those 2 points, now you ask yourself, would the parabola face down or would it face up? So how we determine that? You look at the coefficient of x squared. As you can see, the coefficient of x squared in this question is what? Is positive. So the parabola will open up. So the curve will be something like this. The parabola will pass through here, then open up. Be something like this. So now, the last step is to now shade the required region. So we are told that the value of x now lies from what? -3 to 4, which lies from -3 to 4. So we just shade the region underneath the parabola that lies within that region. So this is how we represent this result on the number line on the Cartesian plane. Now let's look at the last example under quadratic inequalities. So the first thing we want to do now is we want to rearrange this. So we have what? -2x squared minus 5x plus 3 is greater than 0. So we factorize, we multiply this by this, and that gives us what? -6x squared. Then what two numbers can I multiply together to get -6x squared? But when I add or subtract them, I'll get -5x. So that will be what? -6s and what? X. -6s times x will give me -6x squared. -6s plus x will give me -5x. So I replace -5x with this. So I have -2x squared minus 6x plus x plus 3 will be greater than 0. So I have -2x being common here. So I have -2x is common, and I'm left with what? X plus 3. Then I have 1 being common here, and I'm left with what? X plus 3 being greater than 0. So I pick one of those. I have x plus 3 and what? -2x plus 1 being greater than 0. So now what do I have to do now? I have to think about this. So now I'm told that I'm multiplying two terms together, and when I multiply those two numbers together, the product is positive, is greater than 0. So it means that either those two numbers are positive or those two numbers are negative. So scenario 1, both are positive. So if both are positive, it means that what? X plus 3 is greater than 0, and at the same time -2x plus 1 is greater than 0. So when we solve this, we have x is greater than what? -3, and here we solve it, we have what? -2x is greater than -1, and when we divide both sides by -2, if you recall, when we divide both sides of an inequality by a negative number, we have to reverse the inequality sign. So this becomes x being less than half. So let's think about it. You have a number x that is greater than 1 minus 3, while at the same time is less than half. Well, this is very possible. For example, 0 minus 1 satisfy this condition, and let's try to represent it on the number line. So on the number line, you have what? You have your 0 over here, and you have, let's say you have your 1 here. So this represents your half over here, and you have your -3 over here. So here you have -3. X is greater than -3. So x is in this direction, and at the same time x is less than half. Half will be over here. So as you can see, this graph represents was -3 less than x, while x is what? Less than half. So let's look at the second scenario now, scenario 2. So in the second scenario, is either both numbers are negative. So it's either x plus 3 is less than 0, and at the same time -2x plus 1 is less than 0. So here we have x is less than what? -3, and here you have what? -2x is less than -1, and when I divide both sides by -2, I have what? X being greater than half. So think about it. Is it possible to have a number of x that is less than -3, such as -1, -5, and at the same time the number is greater than half? Well, this is not possible if you think about it. So this is what? Nonsensical. So I disregard this. So I stick with the scenario 1, which gives me -3 less than x, which is less than half. So I sketch this now on the Cartesian plane. So first, I sketch out the Cartesian plane, and I label my axis. I have my x and my y axis, and now I know that the roots of this quadratic equation are what? -3 and half. -3 and half. So I know that the parabola is going to cut through the x-axis at x is equals to minus 3 and x equals to half. So I locate that point. X equals to minus 3 should be somewhere around here, and x equals to half should be somewhere around here, and x equals to half. So the parabola will cut through these 2 points. Now, will the parabola open up or will it open down? I check the coefficient of my x squared, and as I can see here, the coefficient of my x squared is a negative number, minus 2. So the parabola will open down. So the parabola will go something like this and cut through at this other side. Now I know that the range of my value now ranges from minus 3 to half. So from minus 3 to half, the region that falls between it is what? This region over here. So this sketch shows the region that falls between what? Minus 3 and half. So this is how you represent this, which is on the number line, towards the Cartesian plane. So this pretty much sums up the basic idea of what you need to know about quadratic inequalities. And I should mention that this is actually something that can be quite confusing and complicated to do and easy to make mistakes. So most times in JAMB, you really wouldn't come across this kind of questions. They only come up once in a while. So if you are finding difficulty understanding it, I would suggest that you not waste too much time. You can just try to strengthen other areas, because there's a high probability that this question might not even appear. But you should make sure that you understand at least the rudimentary part, at least on how to represent quadratic equation on the number line, even if you are not able to represent it on the Cartesian plane. So this will be all for now. So in the next lecture, we are going to talk about absolute inequality.